This question comes from Maya, who asks, what would happen if the moon just vanished? Not slowly drifted away, not exploded, just gone. One moment it's there, next moment it isn't. Well, the nights would be darker. That's the obvious part. Here's the less obvious part. The Earth would slowly go insane.
Let's start with the tides. The moon's gravity pulls on Earth's oceans, creating the tidal bulge we call high tide. Without the moon, that bulge disappears. Tides wouldn't stop entirely. The sun also pulls on Earth's oceans, but solar tides are roughly 46% as strong as lunar ones. So tides wouldn't vanish, they just become weaker, more predictable, and considerably less dramatic.
For most people, that sounds fine. Smaller tides, calmer coastlines, fewer flooded basements. For life on Earth, it's a quiet catastrophe. Tidal zones, the areas that are alternately submerged and exposed by tidal changes, are among the most biologically productive ecosystems on the planet. Crabs, mussels, sea anemones, barnacles, thousands of species of algae. All of them evolved specifically to live in the rhythm of tidal change. Kill the tides, and you don't just inconvenience these creatures, you erase the environmental conditions that made them possible. Further out, ocean circulation patterns that depend on tidal mixing would shift. The deep ocean churns partly because tides force water up and over underwater ridges. Less tidal energy means less mixing. Less mixing means different temperature gradients. Different temperature gradients affect weather systems worldwide. But that's just the ocean. Let's talk about the axial tilt.
Right now, Earth spins on an axis tilted at about 23.5 degrees relative to its orbit around the sun. That tilt is why we have seasons. It's also surprisingly stable, and the moon is a big reason why.
The moon acts as a gravitational stabilizer for Earth's tilt. Without it, Earth's axial tilt would wander. Over tens of thousands of years, it could drift anywhere between near 0 and 85 degrees. A near zero tilt means no seasons. The poles stay frozen, the equator bakes constantly. Seasonal rains and monsoons, which entire agricultural civilizations are built around, would either vanish or become unrecognizable. An 85-degree tilt is stranger. At that angle, the poles would point almost directly at the sun for part of the year. Parts of Earth would experience months of continuous direct sunlight, followed by months of complete darkness. The poles would become the hottest places on Earth in summer. The tropics would experience something closer to a regular day-night cycle than anyone currently living in, say, Norway does in winter. This doesn't happen overnight. The drift would take millions of years. But on geological timescales, it's essentially guaranteed. And the climate disruption would reshape which species survive and which don't. So, losing the moon means weaker tides, disrupted ocean ecosystems, altered ocean circulation, shifting weather patterns, and eventually, over millions of years, a destabilized axial tilt that fundamentally rewrites Earth's climate. Now, there's one more thing: the nights. A full moon is bright enough to cast shadows. Ancient humans used it to navigate, to hunt, to track time. The earliest calendars were lunar. The words month and Monday both come from the moon. Most of Earth's major religions have calendar systems tied to lunar cycles. Without the moon, the night sky gets dramatically darker and dramatically more beautiful. The Milky Way, currently washed out by moonlight for much of every month, would be visible every clear night from anywhere on Earth without light pollution.
That's something, at least.
You'd lose the tides. You'd lose the stabilizer. You'd lose the calendar. You'd lose the werewolves, presumably.
But you'd gain the stars. Every night, all of them, just sitting there, silently judging us for whatever it was we did with the moon.